Earlier on in this class, we started talking about rational expressions, okay? Remember, that's whenever you had to find the common denominator, kind of put them together if you can. But remember, as I said before, when you don't have the equal sign and you're dealing with a rational expression, you're probably going to end up with a fraction at the very end of it. Unless, of course, it simplifies down, okay? But having said that, remember that now we're solving, okay? So we need to make sure that when we're solving, okay, that now we can use a process of like, when we're dealing with fractions, how we get rid of fractions all the time. So let's go back to that. But also, I don't think I included in the notes. Oh, I do. Good. I had to look. Now is the time you got to start worrying about restrictions. Okay, because since we're solving now, we got to realize what restrictive values can we not have. Because we could plug in something and go up, that's not going to work because it's going to create something that's undefined. So having said that, let's go through this little quick example here. I'll do one example of each, like that one I'll leave for the notes. Okay, still pretty straightforward, and so it's actually very simple once you see it worked. But let's do the harder looking one. Okay. So looking at this one, there's a few ways to solve it, but the rule number one always is to factor everything first, okay? So really the hardest part about these is just getting through the process of factoring everything, okay? So I'm going to come in here very carefully and look at this one, and we're just going to start working. I'm going to number these so we kind of know how we're working. So this right here is going to be number one. So let's factor number one first. Notice I have x cubed plus 3x squared. You should notice that you can pull out the x squared out of that. That's going to be the GCF. So I pull out an x squared, and that's going to leave me with what? X plus 3. I will be doing the factoring kind of quickly. Is that okay for everybody? Because by now you should be either A, better at factoring, or B, you know what I'm doing, so you can kind of go back and kind of go, okay, I've got to refresh my memory on this just a little bit. 2, I'm going to go and factor this one now, so I'll come over here. 2, I have x squared minus 2x minus 15. Remember, we're looking at factoring, not solving, so you can't use the quadratic formula on this. It's got to be factorable. If it's not factorable, then you leave it alone, okay? So this one obviously is going to go to, got a pretty coefficient of 1 there, so I can go and put my parentheses down. X in both of them. Different signs, larger sign negative. So I'll put a minus and a plus there. And then how about we do a -5 and a 3? Always good to check yourself, right? -5 plus 3 does give me the -2. -5 times a positive 3 does give me the -15. So we're off to the races. Hey, nice thing is look at the right-hand side. Nothing can be factored, right? We're kind of just done. So we're done with the factoring part. So now what we got to do is put everything back together, okay? I go ahead and put everything back together now, makes it a little bit easier, okay? So let's come in here. I'm going to rewrite everything very carefully. I'm in factored form, obviously. I'm going to have x squared, x plus 3 is equal to x minus 5, x plus 3 is all equal to 4x plus 5, x minus 5. Now is the time right now, before you do any simplification whatsoever, is when you would start looking for restrictions, okay? So notice we have an LCD. I'll do it in blue up here. We have an LCD. The LCD is always the common denominator, which is going to be x minus 5 and x plus 3, which tells me x cannot equal -3 and 5. So if I get to one of those, I've just got to exit out, right? Okay? But now look what I'm going to do. I'm going to come in here and go, hey, let's go ahead and start getting rid of some things. But first, look carefully. Before I start worrying about anything, look what can happen right here. Hey, doesn't that just go away immediately? Right? So that makes things a lot nicer, doesn't it? But now I've still got that x minus 5 to contend with. Okay, since I've gotten rid of the x plus 3, we can now see that it is not a common denominator. We actually have a common denominator now, but I don't care. I'm not trying to combine these. I want to get rid of them all together, so I'm going to divide it out just like I would with fractions. Okay, so once again, rewriting one last time, I'm going to come in here, x squared, x minus 5 is equal to 4x plus 5, all to x minus 5. And let's go ahead and multiply everything by x minus 5. Notice when I do that, what's going to happen? That's going to go away, that's going to go away, that goes away, and that goes away. Or to put it more simply, what I also did, notice this is a proportion. Okay, with proportions, remember you can cross multiply up. Isn't that what I just did? I just took the x minus 5, multiplied it up. That reduces that out. Here I multiplied it up, that reduces it out. Or what I just do, I multiply everything by x minus 5 over 1. Okay, so now look at what we're left with. Let's come back down here and we're going to rewrite this again. Okay, we've got x squared is equal to 4x plus 5. Should be telling you right now that, but look, we're dealing with a power of 2 there, since that says automatically get it equal to what? Exactly, good, equal to 0. So let's rewrite this as x squared minus 4x minus 5, all equal to 0. That's nice because look, I can go ahead and put down that all equal to 0, and I'm going to put an x in both. Different signs, larger signs positive. How about -5 and 1? Does that seem good to y'all? Well, notice I get an answer that says this, x is equal to 5 and -1, but there's a problem with that. What do you see? The 5. What is wrong with it?
It's a restriction.
It's a restricted value, so guess what? All you gotta do, well, for in Hawks, don't put it down. For me, on a midterm, that works just fine. Do we kind of remember that now? I mean, that should be kind of kicking off some cobwebs. You've done this before a little bit, right? Okay. I'm not gonna work this whole one, but let's be honest. Do you see a common denominator? First off, is anything factorable in this second one? No, because rule number 1 is do what? Factor, always factor. Okay, not solve, factor. Right now we're just factoring. Then we look for an LCD. We've only got really one LCD, don't we? What is it? Yeah, so couldn't I just multiply everything by 5x minus 1? Now, granted, on the left-hand side, whenever I multiply everything by 5x minus 1, what's going to happen on that side? It's going to reduce out, right? But on the right-hand side, since there is only a common denominator of 1 here, because remember 1 over 1, you're basically multiplying 1 to 5x minus 1, and that's going to be left on the side. Okay? When you see the notes, it'll be a lot more clear. Are we good with that one? Now, be very careful about that one. When you get to the end, it's not easily solved. It's not really factorable, okay, per se, okay? But it is by the quadratic formula. Remember that things now, just because you're looking to go up, it's not factorable. That means, okay, not factorable. It doesn't mean not solvable. Just because your brain can't figure out what two factors multiply together and add together, no, that doesn't work anymore. You've got a whole bunch of methods on how to factor now and solve. You've got the square root method, you've got completing the square, and you've also got the quadratic formula, okay? And later on, I'm going to give you more stuff for whenever you got powers of 3, 4, 5, 6, 15, 25. Hey, I'm lying. Anything above like 7, you're going to go, Okay. Radical equations. Okay, square roots, cube roots, anything else other than that? Mainly square roots. I'm gonna be honest. It's a lot of square roots with us. But this theory is still sound when dealing with cube roots, square roots, and fourth roots, okay? Look carefully. I can read this, but I'm gonna leave this for you to read. Let me just show you a couple by example, okay? Pretty straightforward and simple. You probably remember this if you took me in intermediate algebra. You remember this from the very last assessment, okay? Rule number one, always rule number one when solving a radical is get the radical isolated, okay? The first example here, you got the square root of 1 minus x minus 1 is equal to x. There is a minus 1 on the left-hand side. We can't have it there. We got to get it to the other side, okay? So let's go and take it and add 1 to both sides. Well, then we rewrite. We got the square root of 1 minus x is equal to x plus 1. How do we get rid of a square root?
Two.
Raised to the power that matches what?
Units.
The index. In this case, it's a 2. So we're going to raise both sides by 2. And notice what's about to happen here. 1, on the left-hand side, the square root is now canceled out. And so we're just left with 1 minus x. But on the left-hand side, remember, there is no rule of exponents that says you can distribute that 2. So you got to split that up, okay, into x plus 1, or use the formula of perfect squares that I've given you before. Most of the time, even me, I just go into the FOIL method. Foiling this out, we're going to have x squared plus 2x plus 1. Everybody good with that? I'm going to draw my lines. I didn't really need to use them on that one, but it is a good habit to get into, especially whenever you're taking a midterm and you're worried that you're going to fail. So, you can really, because of the way you can solve these now, you can take these in either direction. You can go left or right. I'm going to be honest, I'm going to go ahead and take everything from the left side and move it to the right. That keeps my leading coefficient as a positive. That still kind of keeps some doors open for me just in case, okay? So notice I'm going to add x, subtract 1, okay, and subtract 1. Okay, well, this is going to cancel out here, but notice what else cancels out? That cancels out as well. And so then for this one here, we are just left with x squared plus 3x all equal to now 0. Everybody can see that we can factor out an x, okay, and that's going to leave us just with x plus 3 is equal to 0. Let's go and solve this as x is equal to 0 and x plus 3 is equal to 0. And so our answer here is going to literally be x is equal to 0 and -3. Now, anybody remember there's a problem with some of this? Very important. Right there. You got to check your answers on these. Okay, now hear me out, because a lot of students, and I hear them say it, and I've got a first semester, I kind of just let people just say it, but then I realized I'm letting you say something that's a lie, and I don't like that. You are not solving, you're not trying to find a restriction. Okay? Look carefully at this problem, the main problem, the very original problem. Now, yesterday, whenever we were talking, I talked about whenever you have x squared, how many answers are you going to possibly have? 2, exactly. But let's be honest, right now, do you see any x squared in up here at all? No. But through the process of the solving process, just because of our simplification of our tools that we have in math, we ended up with, look right here. That's the very first instance of a square popping up. Okay? What that says automatically is because of that law of algebra, okay, it says, hey, you're going to get 2 answers. It doesn't mean you just found a restriction. It just means you just found what we call an extraneous solution. It's a needless, useless solution, but it has to pop up. It's the rule of math that says once that power 2 pops up, you're going to get another answer. It doesn't mean it's a correct answer. That means one of those doesn't work, which means you got to plug it back in. Okay? When you plug them back in, I'm going to kind of give you a little hint. When you plug it back in, the -3 doesn't work. Okay? Which means you're literally going to have to plug everything back in. Because notice, 1 minus -3 minus 1 is equal to -3. Well, a negative and a negative make a positive. The square root of, then you get 1 plus 3 is 4. Okay? Well, that ends up being 4, right? Square root of 4 is 2. 2 minus 1 is what? 1. Does 1 equal -3? No, that doesn't make any sense at all. So no, you can't do that. But then notice, look at this. If you end up coming in here and putting in the other number, it will work. Okay? You put in 0, it does work. Okay? So, because notice if you put 0 in for x, 1 minus 1 is, or sorry, 1, the square root of 1 is 1. 1 minus 1 is 0. 0 does equal 0. There you go. So it's real quick to check. Okay? So I say that because on your midterm, if one of these questions is on there, I don't think one of these are, I'm going to be honest, this is more tools at this point. There's a lot of graphing on the midterm, or picturing graphs. Don't lose points out because you don't want to take 15 seconds to check an answer. Okay, that's just laziness. Okay, really. I mean, it's more annoying. You think you won, but you didn't. Okay, that's like, running a marathon and finding out you didn't cross the finish line. Everybody good on that one? Okay. Same one works this other way. Let me just kind of show you just very quickly. Okay. Good news. If you end up having one like this on your midterm, I make it nice because notice at the top here, when we move that over, we got this x plus 1 squared. Well, on the second one here, if I moved it over and made you have like an x plus 1 to the 4th, yeah, that means you got to write that thing out 4 times. And then foil, 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 foil. Or you might want to write this down in case you ever have to. Google Pascal's triangle. Okay, it's a really neat little triangle that you can create, and it tells you exactly the powers of everything. You just got to throw in the coefficients. It literally looks something like this, and I'm only going to hint at it. You get 1, 1, and 1. Okay, and then it goes 1, and then I think there's a 2 and a 1. And then notice you get a 1. Here you're going to get a 3. Here you're going to get a 3. Here you're going to get 1. It's how it works. But what it is, all of these right here turn into powers in the foiling process. Okay, so it's kind of neat. Okay, so like if you have to do something like, and I'm going to do x plus 1 to the power of 10. Go look it up on that little deal and just write it all out, and it gives it to you. Okay. Won't really happen a whole lot in this class. Okay, so good news. So look at this one very quickly. I'm only going to rewrite it to an extent that I'll let you do the solving later on. But notice, is the radical by itself?
No.
No. So we're going to need to go ahead and add 2 to both sides. And then we're going to get the 4th root of x squared plus 8x plus 7 all equal to 2. Well, how am I going to get rid of that 4th root?
You're gonna raise it to the 4th power.
Raise it to the 4th power. I'm going to raise the other side to the 4th power too, because you're in algebra. What you do to one side, you got to do to the other side. And then notice I just freeze it all up to x squared plus 8x plus 7 is equal to. Anybody know what 2 to the power 4 is? 2 times 2 is what?
It's 16.
Well, it's 2 times 2?
4.
4 times 2?
8.
Times 2?
6.
There you go. Is it though? 2 times 4? 2 times 2 is 4.
It is 16.
Yeah. I thought it was 32. Checking. I don't trust myself now. 2 to the. It is 16. And I have it in the notes, it's right there staring me in the face, so. So, yeah, 16. Get it equal to 0 again, right? And then you're off to the races. You might have to use a quadratic formula. Right? Okay. Don't get hung up on the fact that everything might be factorable. Okay? We're looking for solving, and how do you know?
Equal sign.
Equal sign. Okay. All right, we good with that one? So far, so good. Get them alone. And other than getting it alone, what's another important thing?
Factor. Restriction.
What did I just highlight?
Checking your answer.
Check your answer. Restrictions were for the other one, okay? Restrictions for this, and I get it because I know I hammer a lot about restrictions on this. We're not gonna have a lot of restrictions on it, okay? You're looking for extraneous solutions on this one, whereas before, restrictions are for up here. These have restrictions because you got a denominator. Here's a good little pop quiz. How do I know there's gonna be a restriction?
It's a variable in the denominator.
Exactly. Variables in the denominator automatically scream there's a restriction somewhere. Because eventually we're going to start dealing with functions. We're going to start going through functions again. Remember that? Okay. Scrolling down, let's look at these. Solving equations with positive rational exponents. We kind of hinted at one of these the other day. Not super bad whenever you realize that all you're looking at is what whenever you see this one. Now this one does look kind of nasty for a split second until you rewrite it, okay, and realize what you're looking at. Remember, when you have x to the 2/3 power, the denominator is always your what? Index. And then the numerator is always the power of the radicand, or the inside number. Okay, remember the radicand is the number on the inside. You don't remember that? Fine, just think of the inside part. So I can rewrite this to something that looks like this. How about the cube root of x squared? Okay. -9 all equal to 0. Well, how about we get that thing alone, right? Let's come in here very carefully. And let's go ahead and add 9 to both sides. That leaves us with x cubed. And then we got a 9. Well, how am I going to get rid of that cube root?
To the other side.
Power 2?
No, to the third.
Power 3, yeah. Thought I heard a power 2. I was like, no. Power 3 on both sides. Anybody got what 9 to the power 3 is?
729.
729. But now look what just happened. I've got a power 2 out there now. So how am I gonna get rid of that power 2?
Where?
Square root it, right? So I take the square root of this side, and I take the square root of this side, and what's something you gotta do immediately? Yes, plus minus. Please don't forget your plus minus there. And then we can do x squared, or sorry, x is equal to what? Plus or minus the square root of 729, which is just 27. There you go. I'm just sorry, I'm looking it over, making sure there's nothing I need to kind of highlight in there. It doesn't really talk about checking your answer on this one too much. I think you're okay on checking your answer. I always still feel like it's always good to check if you can, if you have a chance to check it, okay? Now, could you work the same? Does the other one work the same way? Yeah. What are you actually seeing when you look at this one? When you look at that just mess of a quadratic right there, aren't we really just seeing this? The fourth root of 32x squared minus 32x plus 17 all equal to 3. And as you've all said, to get rid of that guy, I'm gonna raise that to a power of 4. But I gotta do it over here as well. Well, then that just leaves us with, if somebody wants to find out what 3 to the 4th power is. 81. And then I think you're off to the races after that. Now you're just doing what? Get it equal to 0. When you do that, I would like to point out, you would subtract 81, subtract 81. And let's just really look at this just very quickly. You got 32x squared minus 32x minus, my notes say I get a negative 64. I'm about to check my math. I have been known to mess up. I'm only human. Okay. I have found that students are so readily able to call me out on a mistake, and I'm like, I grade your papers. Remember how many mistakes I see. Okay. Do you need to spend a lot of time on it? I mean, let's be honest, right now, you could factor out a 32 if you wanted to, and that's going to give you x squared minus x minus 2. Okay. Which I do in your notes. Or if you're just not seeing it, can you not go straight to the quadratic formula? It would also give you the same answers. You would bypass the factoring and go straight to the solving. Okay. You might try that sometimes. Okay. If you have a way that you're good at, okay, like for me, honestly, quadratic formula is my guy. I sometimes have to force myself to see this because I just literally want to go straight to the quadratic formula and just be like, whatever. Because I mean, really, it's all calculator work. But try to see if you see anything else sometimes. Okay, it's going to open your eyes to other things. Okay, and then you get good. You don't become a one-trick pony. Okay, so because what happens if something doesn't work? Okay, quadratic formula always works. Okay, always. Okay, just not always pretty, but it always works. Are we good with that? All right, let's look at something else. The speed requirement for an object to escape from the gravitational pull of a planet is called the escape speed of the planet. The escape speed is given by the equation. The v velocity, okay, sub e. E is the escape velocity. That's why I can remember those little subscripts. You remember when I told you yesterday? Those little subscripts, you don't get rid of those. Those are literally just by definition something. Like whenever you see stuff like this in movies, okay, that's why I love and hate movies at the same time. I love it when they show all these formulas up on a deal and people are like, man, math is so hard. No, it's algebra. All that right up there is algebra right now. Every single one of those somewhere on another board that they're never going to show you in a movie is this. They're going to have VE, 2GMR. And on that board over there, because it doesn't look cool, they're going to have everything defined. You know, this is what G is, and here's a number. This is what this is, and here's a number. This is what this is, and here's another number. Or they'll have everything already programmed in to where they can just kind of just plop it in. Okay, this is just shorthand. Okay, so when you see stuff like that, realize that's all that's happening. Okay, so let's look at this one, and this says, where V is the escape, G is the universal gravitational constant. Okay. And M is the mass of the planet. R is the radius of the planet. Solve this equation for R. Okay, we're literally just solving for R. I had fun with this one. If you want to have fun, I won't do it right now. But because I talked about the Martian, hint, he's got to leave Martian gravity and he's got to leave Earth's gravity. And so I actually figured out the gravitational escape velocity of Earth and of Mars. Okay, so have fun with that. Go look up another planet going, how fast would something have to travel to get out of our gravity? Like they've already said, if Earth was like 20% larger, I think I'm right about this. I may be wrong. Somebody will correct me. But just 20% larger, we would never be able to leave Earth's gravity. We would be stuck on Earth. We wouldn't have enough power to ever leave it. It would always be stuck. We wouldn't have satellites. We wouldn't have anything. It's kind of interesting. So, but for this case right here, we're just going to do what? We're going to solve for R, just so you kind of get used to. I want you to get used to solving for stuff like this. So we've got V of E, the square root of 2 big G, big M. And yes, when you're given a formula, put down the correct, if it's a big G, it's a big G, okay? For you people who might take physics, because we do have a physics class for algebra, okay? You don't take it with calculus. G is an actual number, and then there's a little g, okay? When you jump off a cliff, you're dealing with little g, okay? Little g is affecting you falling from a plane or whatever. Big G is what's handling the cosmos, like how come we're going around the sun? They're both gravity, but they both have a different number, okay? So how are we going to solve this? What do I got to do first? Don't I have a square root? How do you get rid of square root? Exactly. So let's raise it to the second power. Okay, so we raise everything to the second power, so we know, I'll work this direction. That's going to be V to the E raised to the second power is equal to 2GMR. Okay? Well, now what do I got to do? It's a tricky one.
Get the R by itself.
Got to get the R by itself, but man, that R is in the denominator. How am I going to get that thing alone? Let me give you a little hint sometimes.
By the inverse.
Maybe that might work. Let's see what happens if I multiply by the inverse. That's a good idea. So basically you're saying I could multiply this by R over 1, right? And then, well, sorry, R over 2GM, right? But then what's that going to do over here on the other side? Let's see, is that going to work? So I was going to experiment. Let's see what happens, right? So notice on this side, we're going to get BE squared and then over 1 times R 2GM. Okay, and what's that going to do over here? Doesn't that get rid of, that just gets rid of everything, right? Okay, it cancels everything to a 1. Okay, so we can just put a 1 over here. But now we're going to have this. So let's rewrite. We're going to have VE squared, and we can put an R right here, all over what? 2GM. R is still surrounded by a whole bunch of stuff, isn't it? We might have made it hard on ourselves, don't you think? So how about we go back? That's okay, right? So let's go back. You were on the right track. I want to tell you right now, you were on the very close to right track. So look carefully. Instead of multiplying by the inverse, realize we're dealing with a proportion. A proportion is anything equal to something else, which means I can cross multiply, right? Or multiply by not the inverse, but how about I just multiply everything by R over 1, R over 1, which remember that's R over 1, or cross multiply that up, right? And then we're going to get what? Look at this, VE squared times R is equal to 2GM. How am I going to get R alone?
Divide off the VE now.
Very good. Divide off that VE. Don't forget your square. And then what are we left with? Look what happens here. This, of course, goes to what? That just cancels out. Reduces. Correct me. And you get R is equal to 2GM all over VE squared. Why does that matter? Gravity is a constant. If I know the mass of a planet, mass, okay? Physics talk for a second. You only have weight because the Earth has gravity. How do you know you have weight? Go stand on a scale. I did this morning. Okay, I was not happy. But I had weight. Okay? You send me out into space, and the further I go, the less I will weigh. Kind of makes sense, right? Don't start thinking floating. That's orbit. Okay, but we're not going to get into that. But the less I will weigh, because the less pull I have by this body of Earth. I have the same mass. Mass is the stuff you're made up with. Like if I have this right here full of water, can we all agree there's so many molecules of water in here in this little like bucket? Well, if I take that bucket out in outer space, there's the same amount of molecules in here. That's mass. Okay, so things weigh differently. Okay, the weight changes, mass doesn't. So if you know the mass of a planet and you know the escape velocity, you can find its radius. So then you can find out its size. Okay, so that's what scientists do. That's how come you need to start learning things. When you know certain things, you can go, we don't know this about that planet, but we know this, this, and this. So we can arrange the formula different to learn this other thing and solve it mathematically. Okay. It works for many, 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 many types of equations. We good with that? All righty. There is some homework examples that I'll leave for you to look at. Pretty straightforward. I'll kind of just scroll through them really, really quick. Like that one right there, that's proportion, right? A lot of ways to solve that one. You can multiply straight up, okay, cross multiply. Or you could say, hey, I have a common denominator of 30x, right? 5 times 6 is 30. Got x on both of them. Do it that way. You've seen that. Am I solving or am I simplifying? Solving, exactly. This one right here, you're solving for, what are we solving for? Solve for k. Almost exactly what we just did, isn't it? Almost. And then you got that one. So pretty good. You got a pretty nice professor to give you all these examples. So. That one looks a lot nicer and to solve whenever you put it actually in the form, right? Because don't you actually have the 5th root of x minus 3 squared is equal to the 5th root of 10x minus 54? Basically, raise everything to the power of what? 5. FOIL solve. See? If I'd have shown you that in day 1 of intermediate algebra, I wouldn't be having you right now. Okay. All righty, let's jump into 2.1. 2.1 is not due till next Friday. Remember, next week, everybody, starts your process of you're going to start having that Monday, Friday homework, okay? So that grace period of that is done, okay? But now we're going to get far enough ahead that hopefully you're getting ahead that this is not going to be so much of a like burden, you know? But it's the only way to keep things on track. Okay, it's either that or I give you like all your homework in one day, which I can do. If y'all would rather have all your homework due just one day, we can do that. But I have found in the past that tends to cause people a lot of anxiety when they wake up and realize they've got 7 or 8 homework due in just one day. So the intermediate algebra class online is feeling that right now because they have to have it that way. They go through a lot. Okay, so. You all went through intermediate. Imagine doing it in the summer for 8 weeks. All right. 2.1. Very simple. Chapter 2 is going to be pretty straightforward. It's going to have some freaky parts to it, stuff that you've kind of seen before, but done once again a little bit on steroids. And a little deeper. So notice here, Cartesian coordinate system. First time you heard me ever talk about that was you took me for Dev 2 or elementary algebra when I started teaching you how to graph points. And surely you're thinking right now, you're surely not Professor Clark, not going to teach us how to graph in a college algebra class. Au contraire, I am. But we're going to take it deeper. Ordered pairs. An ordered pair AB consists of 2 real numbers, A and B. Unlike sets, the order of the elements in an ordered pair matters. Remember, sets Those are those things y'all are doing. Remember we'd have parentheses, you can't equal, but you have brackets, they equal. Now we're talking about ordered pairs. These are going to be points, okay? That is, AP is not equal to B and A. You can't flip those. Unless A equals B, okay? In a given ordered pair, A and B, the number A is called the first coordinate, or what we would like to call the X value. And B is called the second coordinate, or what do you think?
1.
Exactly. Okay, very simple. Ish. The Cartesian coordinate system, also called the Cartesian plane. We call it a plane for a reason because it is a plane. If you add in another variable, you become a space, 3D. Okay, you will not learn about that until you get into Cal 3. For those of you who go that way. It consists of two perpendicular number lines, each called an axis. You know this, intersecting at the 0 point of each line. What is that 0 point?
Center.
What is that guy called right there?
Intersection.
Origin. So when you hear that word origin, you know it's 0, 0, okay? That's it right there.
Oh.
The point of intersection is called the origin of the system, and the four corners defined by the two lines are called quadrants of the plane, numbered as indicated in figure 1, which I don't give you figure 1 because I'm going to give it to you right now myself, okay? Because the Cartesian plane consists of two crossed real lines, it is often given a symbol of r times r, or that r squared. Notice how it's just not a regular r. That is the real number, because you're dealing with what? A real numbered line x-axis and a real numbered line y-axis. That's how come we call this the real number squared, okay? I say that because if you see in your math book, you don't freak out by symbols. You go, oh, that's just the Cartesian plane. That's just their symbol for it, okay? Reason they do this is because sometimes when we solve things, things will cross into other planes. I may solve something here, but my answer may be a complex number. So I'm crossing into a different plane, and so we will show that mathematically sometimes, okay? Few of you want to show that, okay? I'm just saying that's how come things happen. And then once again, each point is plotted. Now, I promised I was going to show you the, what do you call it, the quadrants. I will show you that in the next example. So, looking here. Going to graph this. I'm going to graph A on this first part here, and then we're going to graph B. Okay, A should be easy enough because look, we're going to do A first. Okay. Now, just real quick to do our quadrants. Does anybody know the quadrants? First off, you know what a quadrant is. It means four, right? We define them by Roman numerals, okay? And they go backwards, okay? So you would start here, 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 and then here, okay? Very important to know that. It may not seem important, it is important, I promise you. It's something that its importance really doesn't come to fruition until you're in trigonometry, okay? But it's still, remember, you're playing the game of football, but you never get to go play in the NFL. That's not what you're doing, unless you go that direction. Also note, it's always good to know that everything in quadrant 1 is always going to be a plus and a plus. That means my x and y value are both going to be pluses, aren't they? They're both positive. If I keep going with this, over here, they're going to be a negative and then a plus. Everything in quadrant 3 is a negative. And then in quadrant 4, the x values are positive and the y values are. That is included with your notes, by the way. A few ways we can solve this A to find a line, but let's just go ahead and do it the old-fashioned way. Come in here very simply and do this. You're going to come in here and go X and Y, right? Remember that? What do? We just pick a value, right? So let's just pick, I'm going to use my ones in my notes here. I'm going to pick a value of 5. And then I would come over here and go, okay, well, 2 times 5 minus 5y is equal to 10. that's gonna be 10 minus 5y is equal to 10. Subtract 10, subtract 10, I've got negative 5y is equal to what? 0. Divide off the negative 5 and I get y is equal to 0. And there is a point, correct? So I gotta come over here, you always do your x value first, so I come over here to 5 and 0, and there's my point right there. Everybody see the black okay? Or do I need to go to a different color? Can you see? I know y'all, and also don't forget, if you can't see, you can always turn around. They're right behind you there. Okay. But am I done? How many points make a line? 2. 2 points make a line. Now, let me tell you this. How do I know I'm making a line? How do I know this is going to create a line?
No powers to the x,
Well, there is. There's always powers.
higher power.
Exactly. There's a 1. Okay. So notice there's just a 1. Everything up here is a power of 1. That tells me this is going to create a line. Okay. Do it one more time. I'm just going to give it to you. I'm going to let you solve it later. I put in 10. When I go through the whole solving process, I get a 2. So come over here. I can go over to 10 again, go up to 2, and then, oh, look at that. Now I've got a nice little line that I can graph. And I don't care what y'all say. That's not a bad looking straight line for a guy who's having to do it kind of away like I'm painting. So a good review here. Let's see who can help me out here. What is the domain of that line? Remember what domain is?
Is it the distance of the points?
Negative infinity to positive infinity.
Who said that? Very good. It's negative infinity to positive infinity, or all real numbers. Remember, domain is your x. Okay, we're not really dealing with domain yet because that's really whenever we start dealing with functions. But look, that's where it's saying this. I've got a line. Where's that line stopping? Is it ever going to stop? It's going to keep going. That means if I'm walking along the x-axis and looking down, that line's going to be there, no matter what. If I look up, eventually it's going to be there. There's going to be at some point I'm going to watch it cross that x value and I'm going to see it going up, but it's always going to be there. From negative infinity to positive infinity, it's always been there and it always will be. So that's why it's got a domain of all real numbers. Well, what's my range then? Range is always from bottom up. Remember, domain is always left to right. So if range, if you're climbing a ladder.
Right. I don't know, I'm confused. 'Cause I thought it was like where you go over from the x-axis and go up to the points.
You're thinking slope.
Oh, okay.
Don't think slope. We're thinking of all of them. So what will be my range?
All real.
Range is always what people have trouble with. All real numbers again. Look. Negative infinity to positive infinity, or all real numbers. Is there ever going to be a spot ever on this line? Oops. That line's not going to be there. That function is not going to be here. Look, I'm coming up, right? Can I look to the left and see the line? Keep going up. Can I look to the right and see the line? If I go up to 1,000,000, am I going to be able to look up and be able, in the distance, still see that line? There's your range. Okay. It's always good to review, isn't it? We're going to study domain and range a lot. So this is what a little precursor. We're not really study in this lesson, but I do kind of want to keep it going. Well, now let's plot the ugly one. Let's do B. I'm only going to give you like 1 point on this one, because I'm going to tell you right now, this is an easier one to graph on Desmos. Okay, but let's look at it very carefully. I'm going to go ahead and start plotting points like normal. I'm going to come in here and go, okay, I'm gonna need to make myself a little bitty XY little chart here. But this one looks a little bit harder, doesn't it? Because notice you've got an X squared, but you've also got a Y squared. What happens when you square both of them? Have you ever had to graph anything that had two squares in it? No, you're either going to graph a what? A Y squared, or you're going to graph an X squared. X squared, y'all should know what that is. That's a parabola, right? Well, a Y squared would be a parabola as well. It just is hanging on its side. Well, what happens when you got both? Let's see. Let's put a 3 in. Okay, I'm putting a 3 there. So let's come over here and go, okay, I've got 3 squared plus y squared minus 6 times 3 is all equal to 0. Well, that's going to give me a 9 plus y squared minus 18 all equal to 0, correct? Now I've got to combine like terms, right? Okay, 9 minus 18 is going to give me what? 9, exactly. No, not just 9. Yeah, 9. No, not just 9.
-9.
-9, thank you. So then I'm going to have this. Y squared minus 9 all equal to 0. Hey, but you know what's nice? Look at that y squared. And look at the minus. And look at the 9. What do you see there? I'm going to start writing it and all you're going to go, duh. A difference of squares. Remember that little difference of squares there? So this got factored automatically into what?
3,
Y plus 3 and what?
1 minus 3.
Remember that? Okay, so notice, well, that's weird. So you're telling me right now, so I know that this is going to turn into what? Y is equal to -3 and 3. Okay, so that means I got to come over here, right, at 3, which I'll just put a little dot there, right? Well, then where do I go now? Can I go up to 3? Don't use that. That was not my highlighter. Isn't that one of my Y points? Right? So let's come over here and put a 3 here. So there's a point. But then I've also got one where? At -3. I got 2 points out of that. So here I would have 3, 3, and 3, -3. You can do it again. It's going to happen. But it's really kind of hard to see what's happening, isn't it? Okay, so let me just kind of show you real quick. If I do 5, is everybody okay if I erase this? I mean, all my notes are down. So let me go and just erase so I have room instead of having to get off the deal. I want you to kind of see what's happening. You're still solving right now. Okay, so let's kind of come back in here, erase all this, and let's do the same math again. I'm going to have 5 squared plus y squared minus 6 times 5 all equal to 0. That's going to become 25 plus y squared minus 30, all equal to 0. 25 minus 30 gives me, how about y squared minus what? 5, all equal to 0. That's not a difference of squares, is it? But that's okay. You know why? Because you have the square root method. So I can come in here and say, hey, how about this? How about I add 5 and add 5? And that's going to give me y squared is equal to 5. But hey, how about I take the square root of both sides, put a plus or minus there, and I get y is equal to plus or minus the square root of 5. And if you look up the square root of 5, you end up getting 2.2. So I get plus or minus 2.2. So once again, I've got 2 more points. One at 2.2, one at -2.2. So if I come over here to 5, Can we all agree that 2.2 is roughly right about there? Roughly right about there. Oops, not there. 2.2, not 1.2. What am I doing? 2.2. Now I say this because when you do this in Hawks, they don't want you to graph a whole bunch of points. Okay, I mean, I think they want you to give him like 4 points. So I gave you my 4 points, didn't I? And we just said, we found these points by doing what? Doing the math, factoring correctly. Now, let me tell you what you actually do end up with. If you kept graphing and graphing and graphing, is you would end up with a circle. Anytime you have y squared and x squared, you end up with a circle. You know how I know that? 2.2, we'll get to that tomorrow. Okay, but there you go. Does that tell you why now you were getting those two answers? Okay. You could have gone the other way and notice you would have got more. Doubles, doubles, doubles. Until eventually you solved enough. Okay, if you solved plenty of times, like notice, okay, it's actually kind of nice. If you've tried to solve where y is 0, wouldn't that be the x-intercept? When y is 0, right, that's the x-intercept. Look what happens when you solve for 0. I'm going to just do this in red real fast. Well, if y is 0, doesn't the y squared just go away? Can we all agree with that? Because I'm making y 0. So then I can just rewrite this as x squared minus 6x is equal to 0, but that factors out to x what? Minus 6, all equal to 0. Or x is equal to what? 0 and 6. If you actually did this correct and you drew better than what I did, you would actually get a circle that looks more like this. Zero, 6. Kind of neat. I like it. I teach math though. I like this kind of stuff. But it is neat how things start making shapes after a while. Okay. So if you're graphing and it's not making sense, then there you go. Sometimes that's what's happening. Okay. But we were able to find it out by what? By just doing the math. Okay. When you do this in Hawks, they're not going to say, hey, graph this and know what it looks like. They're not. They know at this point you're not going to know. Okay. I'm saying you graph enough points, you can find it out. But also, don't forget to go in there and use Desmos sum. Okay. Don't use it to cheat. But go in there and start learning what these graphs look like and go, oh, wow, that makes a circle. That's kind of neat. You can also use it to check your answers to make sure they're correct. Okay. All the little numbers you put in. Okay. All right, let's get to some formulas because everybody loves formulas. Distance and midpoint formulas. Notice we have a triangle here that has a point. We have a whole bunch of points, right? We have the point of x1, y1. That's just point 1. And we have the point x2, y1. Then we have the point x2, y2. We have 3 different points. Those 3 points, when you combine them together, okay, create what? A nice little right triangle. Okay. And then you're seeing here we have something called D. This is called the distance formula. Okay, which actually, believe it or not, is not as bad as what you think. Okay, you're looking at that going, holy crap. Let me show you something. I'm dealing with a distance, right? This distance, if I decide to show this to you differently, can we all agree that we're dealing with a triangle, a right triangle, right? Triangles always have legs A, B, and C. Okay. That should harken back to a nice little formula of A squared plus B squared is equal to C squared. Well, notice A we're going to make equal to that distance. And notice how they're deciding this A distance. They're saying, hey, if you take this x2 and minus it from x1, you're going to get a distance here. That's why they're doing what? They're putting it an absolute value symbol. Because if you accidentally subtracted x1 minus x2, you might get a negative value, right? But when I take the absolute value of a negative, what happens? It goes positive because absolute values denote what? Distance, okay? Which is so when I come up here and go x squared, or x2, not x squared, I apologize, x sub 2 minus x sub 1, I can do the same thing with b and get y sub 2 and y sub 1 because we are going in the vertical direction now, not the horizontals. Another way to give yourself always a positive number is what? Think about it. Let's step into the mathematical world. If I have a negative 1 and I want to make it positive, how do I make it how do I make it positive all of a sudden?
5 by negative.
Could, or could I square it? Yeah, I could square it, right? Negative 1 squared is 1. And if I want to get back to that original 1, let's make it harder. If I have a negative 2 and I want to make it positive, I can square it. That's going to give me a 4, but that's no longer the 2 anymore. So I'll take the square root of it. It knocks me back down to my original 2, and now I've got a positive number I'm dealing with. Okay? So having said that, notice that's why the formula turns into this. C is going to equal the distance I'm looking for. So when I put all this into my formula, I can say, hey, D is equal to, well, x2 minus x1. Remember, you got to put everything squared, right? Because that's what the formula up here says to do, right? Plus y2 minus y1 squared, but I don't need things squared. I mean, it will work, I guess, but couldn't I come in here and just take the square root of both sides? Now, being that we're dealing with distance, do I need the negative? Can you have negative distances? No. So this turns into our formula of D is equal to the square root of x sub 2, x sub 1 squared plus y sub 2, y sub 1 squared. So literally realize all you're seeing when looking at this, is I really want you to realize, is you are seeing this right here. That is that. That's all you're doing. You're saying, hey, I have a point from here to here. What's the distance between here and here? That's it. An example. Distance formula, there it is again. So they give me 2 points. Now I want to tell you right now, I'm not going to do this both ways, but I want to show you this on your notes. Now you won't be able to see it through the lecture here, but on your lecture notes, I do show you it does not matter how you subtract these, okay? What you should remember is just label, start labeling more, okay? So notice, let's come in here, and I'm going to label this one as x sub 1, y sub 1, x sub 2, y sub 2. Remember, all that's saying that x, well, that's my first point. Then I have a second point. And I want to know the distance between those 2 points. You know why? Because maybe those distances I put down on a map. I know I get it. Y'all got Google Maps now. Once upon a time, you actually had to have maps. But I want to know the distance between these 2 things. Okay, so if I have 2 points, I can tell you the distance between them. Okay? So we're going to come in here. Let's pop everything into our formula and realize that we're going to have D is equal to the square root. Well, my x sub 2 is negative 7. The formula says I'm going to be minusing, so I'm going to minus my x sub 1, which is going to be a negative 4. Close that off and don't forget to square it. Plus y sub 2 is 2 minus a negative 2. Close that off and square it. And there we go. Now we're going to take the square root. So let's clean this up. Let's keep going with this. -7 turns into -7 plus 4, right? Because that negative and negative make a positive, so -7 plus 4 gives me what?
-3.
-3, exactly. So I'm gonna have right here, -3 squared. Don't forget that square on the outside. Matter of fact, you need to put it in your calculator the exact same way. -2 plus 2 turns into 2 plus 2, which is just gonna give me what?
4.
4 squared. -3 squared turns into what? Negative and negative make a
Positive.
3 squared is 9. So you're just gonna have 9 plus 16. 9 plus 16 is 25. And the square root of 25 is? There's your distance. So that, if you graph those, that would be the distance of those 2 points. Now, if they were standing in a straight line, that'd be awesome, where you just go, okay, 1, 2, which actually these aren't. I'd look at it like, are they? Nope, they're gonna be cockeyed just a little bit. So you can't really just go, have you all tried to do that where you try to count the squares, but then you're like, okay, this is missing a little bit, but there's the other part where it kind of catch. This gives you the exact distance, okay, between. In your notes, take time on here. In your notes, I do this. I erase those points. Pardon myself here. And I do this. I come in here and go, what if, I always like to prove it to you, what if I did this here, x2, y2, x1, y1. I flip them around. We still get 5. Why? Okay. I'm gonna give you all a little hint about something real quick. First off, every single one of you, the smartest people I know today. I know because I hang around a lot of stupid people. It makes me feel better about myself. 2, if I told you, hey, how far is it to Lubbock? And you all said, give me a distance from here to Lubbock. Okay, 100 miles. How far is it from Lubbock to Hobbs?
100 miles.
How come all of y'all couldn't tell me the distance between this point to this point, this point back? It's the same thing. It's a distance, right? If I go from point A to point B, it's this distance. If I go from this point to back, it's going to be the same distance. So I always say, take your mathy brain and keep it in the side, okay? Don't worry. I'm not going to ask you trick questions, okay? So yeah, you better get the same answer because it's the same line, same distance, okay? But I wanted to prove to you that it works. Let's do one more little formula real quick here, and then we can call it a day. Then we'll go through some homework examples, and this will be 2.1. Okay, now be careful in your homework. Okay, let me tell you right now, be careful in the homework. The homework for this one's a little bit tricky. You're gonna want to use the tutor and look at my notes. One reason is this. It's gonna start asking you some weird questions like how far is it from this point to this point, but it's gonna say the tangent of this point. Or it's going to say from the origin of this point, or it may start asking you some weird questions. When you tutor it, it's going to be able to answer it. I also give you an answer, or you can also do what? What's another important thing you can always do?
Text message, email you.
Email me. If you get a weird, it's like a tangent, okay? Okay, so just email me. So let's look at one more little formula. It's called the midpoint formula. Midpoint. Basically, it says, hey, if I give you a whole distance, okay, could you find me a point in between there? Well, yeah, if you give me this point and this point, isn't that just the average of them? That's what it's saying there. It's saying if I have 2 different points of x1 and y1 and x2 and y2, I can find a brand new point. The point in between them. That's kind of nice, isn't it? So let's do that. Let's come in here and go, okay, well, how about I do this? I have that x1, which is going to be a 5, plus that -1, all over 2, comma, 1 plus 3 all over 2. I'm going to close it up because am I not creating a point right now? That's why it's called the midpoint formula. Hey, 5 plus -1 just turns into 5 minus 1, right? So 5 minus 1 is 4. 4 divided by 2 is. Hey, 1 plus 3 is 4. Divided by 2 is. There you go. So if I graph both those numbers, 5.1 and negative 1, 3, the point that would sit directly in between, like dead center, between those points, okay, like here's one, here's the other, the point dead center would be 2, 2. Now, does that mean you're always going to get pretty numbers? No, but it's still a valid point, okay? That can help you out a little bit. Now, I say that because on some of your homework, and I'll show you here whenever we do some of the examples. We won't today because I'm out of time. When we do some of these examples, you're going to say, sometimes I need to use the midpoint formula to find out something that it's asking me a distance of. Okay, because it may be asking for a distance from here to here. Okay, but it only gave me points from here to here. And so like it may be giving me a diameter and I need to find the radius. Kind of makes sense a little bit? That might be a bad example, but still, when we go through some of the examples, you'll be good to go. Little bit. So when I did tell you, hey, we're going to start studying the Cartesian plane again. See, I told you it wasn't going to be like it was in chapter 10. It's going to be a little bit more in depth now. Okay. Any questions? We all good? Are we going at an okay speed for everybody? Not too fast, not too slow. Early morning class, bring more coffee.